This conference will now be recorded.
Yes, okay. So MongoDB, how to connect MongoDB with the database? Everything is done, right? Yes or no? Yeah, fine. Now, Radha, did I give any definition with respect to your, what do you say, threading? Yes or no? So, what is threading? You can speak out. Sashi? Yeah, you can speak out. So, what is meant by threading?
It is a lightweight process which is used for performing various operations.
Okay. So, how many ways to create a thread?
Mm,
Did I
There
mention
are
that?
two different algorithms are there.
Algorithms గురించి కాదు. How many ways to create a thread అనేది ఏమన్నా చెప్పినానా?
చెప్పలేదు.
Okay. So, what are the algorithms?
Consumer problem, dying, philosopher problem.
Both I have explained.
No, only just what are the names you have explained, not about the.
Okay. Fine. First, we'll go for consumer producer consumer problem. Okay, na?
That can you explain that how you can create the thread?
Yeah, I'll explain about how to create a thread later. First,
Okay.
we need to know about these algorithms. Then I'll explain about that. Okay, na? Hmm. Can I start?
Yeah.
Hmm. Okay. Are you able to see my screen? Sashi, are you there? Now, see here. First one, producer consumer problem. Producer consumer problem, basically, this is a problem which is designed between two people. Okay, na? Which is designed between two people. Say, there are two people available. Let's assume these two are the people. Where one person, this person is called as producer, and this person is called as consumer. Okay, na? Where this one is called as clay pot. Clear, right? Any doubts so far? No. Okay. Now, say, producer, this person, he knows only two things. One is producing the food, otherwise sleeping. Producing the food, otherwise sleeping. When it comes to consumer, he knows only two things. One is consuming the food, otherwise sleeping. Is that clear?
Yes.
Producer knows only producing the food, otherwise sleeping. Consumer knows only consuming the food, otherwise sleeping. Now, here, For producer to produce the food and to store the food into one container, he need this clay pot. To produce the food and to store the food, he need one container, that is this clay pot. When it comes to consumer, to consume the food, he needs that particular clay pot. Is that clear?
Yes.
Yes. Now, here the restriction with the clay pot is only one person can insert his hand at a time. Remember this point. Only one person can insert his hand at a time. If both the people, if they try to insert the hand at the same time, this pot will break. Remember, if both the people, if they insert the hand at the same time, this pot will break. This is what called as your deadlock situation. Clear, right?
Yes.
Any doubts so far?
No.
Okay. Fine. So what we have to do, we have to make sure that only one person will insert the hand at a time. Is that clear? We have to make sure only one person will insert his hand at a time. How we will make sure all those things is what we are going to learn in this particular producer consumer problem. How can you make it possible? How can you make it happen? Using Jilla. What is that Jill? Hmm? Okay. So here, if you consider producer and consumer, both the people as functions, what happens over here is even this person, first, let's say if producer started using this particular clay pot, he will not give the chance global interpreter lock. No, not exactly. Okay. See here. If you consider this particular producer as a function, what we will be doing over here is, if producer is a function, he will come and he will occupy this particular clay pot. Where, as I said, function is just like a selfish component. Correct, right? Function is a selfish component. When he occupies this particular clay pot, he will not give the chance for consumer. Consumer will be keep on waiting only until producer work is done. Is that clear? Yes or no? Where this kind of things should not be encouraged. For this, what we will be doing is, we have to make them to behave like a thread. Okay, now we have to make them to work and behave like a thread. Now, in this situation, what we will be doing is thread. If you make them as a thread, where this particular person, he will be performing operations on this particular plot. Whenever he is performing operations on this particular pot, that means when he is producing the food, till the pot is filled up, this consumer will be in sleeping mode. That means they both will come to one, what you say, mutual understanding. They will decide, when I am producing the food, you please go to sleep. When I am consuming the food, you please go to sleep. With some mutual understanding, they will be sharing this particular resource. So there will not be any deadlock situation. Is that clear? Yes or no? Yes. So this is how you can solve the problem, that is producer consumer problem, whenever if you have two threads associated to one resource. Okay, na? Can you have the next one? Next. See, if you have two threads, then how to solve the issue we got to know by taking the help of producer consumer problem. Let's suppose if you have, what you say, more than two threads, then how to solve the issue is what we need to know. Is that clear? Yes or no? Yeah. For that only, we have to take the help of, what you say, dining philosopher's problem. What is dining philosopher's problem? Any idea? No. Okay. See, this is a problem which occurred at dining table. This is a problem which occurred at dining table. That's why it is dining philosopher's problem. And that too, this problem occurred between the philosophers who are thinking to have dinner. Between them, there is a problem. That's why the problem name stands as dining philosopher's problem. Is that clear? Yes or no? Yeah. Now, here, totally, we have got 5 philosophers. And who are philosophers? Who are philosophers? Philosophers are the people who will give speeches, like our Babas. Got my point, right? Who will be giving speeches. Those people are considered as philosophers. Is that clear? Okay. Now, here we have to consider 5 philosophers. And that too, these 5 philosophers are not from India. They are from China. Why I am considering these people from China in the sense, let's say, if I serve you the food, how will you have? If I serve food to you, how will you hand? Shashi, Ramesh, if I give you the food, how will you have? This is what my question. Are you guys there with me? Yes. Tell me, how will you have? Indians in the sense, we will look for spoon. If spoon is not available, we will go with hand and we'll have the food. Correct, right? Yes or no? Yes. Where these people are from China. Chinese people, how they will have the food? No, not with the spoon. How they will have? Sashi,
Yeah.
how they will have?
With the sticks.
How many sticks?
With the 2 sticks.
Yeah, they need 2 chopsticks. Okay, na?
Yeah.
They need 2 chopsticks to have the food. Where here the problem is 5 people are there. We have got only 6 chopsticks with us. Is that clear?
Yes.
We have got only 6 chopsticks with us. Where these people, if they fight, let's say this person will take 2 chopsticks, this person take 2, this person takes 2, this person will be pulling from him, he will be pulling from him, he will be pulling from him. Like this, nobody will have the food. Correct now?
Yes.
He will be pulling from him, he will be pulling from him. Like this, they will be pulling spoons from, I mean chopsticks from their neighbors. So nobody will have the food properly. In this
Yeah.
situation, what happens? Because of chopsticks, the deadlock situation came.
Yes.
Now, to solve this problem, what we have to do, we need to know what works they know. They
Yes.
know only two things. One is eating the food, otherwise reading. Got my point, right?
Yeah.
Eating the food, otherwise reading. Reading for gaining knowledge, they will be reading the books. So what we have to do, we need to make them to come for one particular understanding. That is threading concepts. If we make if we make them to work like a threads,
Yeah.
three people will be eating, two people will be reading. Three will be eating, two will be reading. Three will be eating, two will be reading. Like this, we can make them to work like a threads so that there will not be any deadlock situation. Got my point, right?
Yes.
So this is what your dining philosopher's problem is all about. Okay, now?
Yeah.
Okay. Now we'll go for next one. So these two algorithms, if you observe, in a producer consumer problem, to avoid deadlock situation, we are delaying with the help of sleep. Correct now?
Yes.
Where here, to avoid deadlock situation, we are delaying with the help of reading. That means some
Okay.
alternate job we are providing to them. Because of their alternate job, deadlock situation is not coming into occurrence. Correct, right?
Yes.
So this is what our major, what you say, concept behind our threadings. Not only here in upcoming, whenever I say threading, in the sense this kind of situations will come into picture. Remember this point.
Yes.
Okay, no?
Yeah.
How we can implement this particular threading is what we are going to see right now. Okay, right on heading, possible ways to create a thread. Possible ways to create a thread. Okay, na? Possible ways to create a thread. There are two different ways to create a thread. Those are first one, by underscore thread, by underscore thread. Second one is by threading. By threading. Okay, na?
Yes.
Where among these two ways, underscore thread will not be preferred because it will not be having proper life cycle methods. It won't make multiple threads to come into picture for performing operations. That's why underscore thread is not preferred. Is it clear? Yes or no? Okay. So first let me show you underscore thread. What is the problem? We will get to know. Then we will go for threading concepts. Okay, na? See, this underscore thread, this is simply waste, as I said. See, we are importing underscore thread. We are importing time module. Next, we have got one function. How that function will get invoked, you can see. Underscore thread dot start new thread. That means we are calling this function as a thread. Got my point, right? We are calling this function as a thread. And that too, for that function, we are passing thread name, thread delay, thread counter also. So first counter it is 3. We are making it to sleep for what you say 10 seconds. After that we will print. See, thread name is this first parameter will be replaced with first parameter. See, first s will be replaced with first parameter. Thread name will be printed. Time is this second s will be replaced with second parameter. That means current time will be printed. Is that clear so far?
Yeah, yes.
Yeah. Then we are decreasing the counter. So second, totally 3 times it will be performing. Again, we will be delaying for 10 seconds. We'll print a current thread name as well as time. Again, next time like this, 3 times it will perform. So first thread is done. Whenever first thread operation is done, second thread will not be executed. Remember, because of underscore thread issue, second thread will not start it up. It will fail there only. It will raise an exception and it will come out with the except block. See? With 10 seconds delay, it executes. You can see thread name is 1, time is this one. Again, after 10 seconds, we will get one more. Thread name 1, time is this one. See, 10 seconds gap is there. And one more will generate and it will go for exceptions. Okay, na? Yes or no?
Yes.
Yeah. This is not highly preferred, as I said, because here once first thread is completed with its operation, second thread there is no chance of getting executed. It will go for exception. So you have to make sure that you are using the threads properly. Okay, na? Fine, right? Yes. So ignore this concept. We'll go for threading. Right on? Threading. It is a process of creating a thread by deriving the features of threading class is called as creating a thread with threading. Creating a thread with threading. Okay, na? Yes or no?
Yes.
Yeah. See, actually, whenever I say thread, threads as per the rule, as per our any technology rule, it should follow certain life cycle methods. But when it comes to underscore thread, it is not following any life cycle methods. Is that clear? It is not following any life cycle methods. It is just we are starting, that will perform, and it will terminate and it will come out. So this is one more reason why underscore thread is not preferred. Okay. Can I have the next one?
Yes.
Now, using underscore threading, we will be, what you say, performing all kinds of operations, as well as we will be following life cycle methods also. What are those life cycle methods? How this will be there? We are going to see right now. Right? Life cycle methods of thread. Life cycle methods of thread. First one. Start. Start. Start is a life cycle method of thread which is meant for creating and starting the thread. Which is meant for creating and starting the thread. Is that clear?
Yeah.
Next. Once the thread is started, it looks for run method. Available in the thread. Okay, na? Yes or no?
Yes.
Next, write down about run. Run is a life cycle method of thread which is meant for run is a life cycle method of thread which is meant for holding the business logic for performing the operations once the thread is started. Okay, na? Yes or no?
Yes.
Next, write down about sleep. This is a life cycle method which is meant for suspending the thread for a number of milliseconds based on the parameters passed to the function. Okay, na? Yes or no?
Yeah.
Yeah. So these are the three important life cycle methods what we have to consider. Start, run, and sleep. Is that clear? Yes or no? Hello, are you guys with me?
Yeah. Yes. Yeah.
Yeah. Now, let me show you. Yes. Observe this one very carefully, okay? Na? See here, we are importing threading as well as we are importing time module also. Got my point, right? Yes or no? We are importing threading as well as time module. Okay. See here. F equal to first, F dot start. See, we are creating an object for first class as well as we are starting up our first class. First class, that too as a thread we are starting. Is that clear? Yes or no? Yes. So now what happens? Control will get transferred to first class. See, class first, it is deriving the features of threading dot thread. From threading module, thread class, it is deriving the feature. And we have got run function. You can see, as per lifecycle method, we have got run function available. What this run function is doing for I in range of 10. So what range function will be doing? It returns the values from 0 to 10. So 0 will be stored, will print I equal to 0 as well as current time. Is that clear?
Yeah.
Will print I equal to 0 as well as current time, and we will go to sleep for 1 second. See, here as this is a thread, when the control is, when the thread is sleeping for 1 second, control will not wait there only. Got my point, right? When a thread is sleeping for 1 second, control will not wait there only. Control will get transferred to this one. See, here we are creating an object for second thread. We are starting up second thread. Okay, now? We are starting up second thread. So control will come to this one. So even this is printing 0 current time. This is going to sleep for 1 second. When this is going to sleep, by the time that will wake up. So from there to here, here to there, the control will be shuffling. So you'll get the result as like this. Check it out. I0, J0, I1, J1, I2, J2. Like this, with some understanding. When that is sleeping, this will wake up. Then this is sleeping, that will wake up. With some proper understanding, they are sharing the resource, like producer-consumer problem. Got my point, right? Yes or no? Yeah.
Yeah.
So, in this case, if you observe, the delay between first thread and the second thread is proper. Even first thread is going to sleep for 1 second. Second thread is also going to sleep for 1 second. Because of which the mutual understanding is proper. Okay, no?
Yes.
Where these kind of proper delay need to be provided, proper understanding need to be there between first thread and how many ever threads are there in your program. For all the threads, you need to have proper delays like this. If you are not having these kind of proper delays, what happens? It will not behave like a thread. It will behave like a functions, and again, it will be simply wastage only. Remember, first thing. Okay, now? Yes or no?
Yes.
Yeah. Now, here, one important thing what I have to say over here is, in this program, we have got two threads. The names of the threads by default, it will be, you can see, first thread name is thread-1. It is started with the port address. Thread ID is 14908. Second thread name is thread-2. It is started with this particular thread ID. Is that clear? Yes or no?
Yes.
Using threading.current thread, I am printing the information about that particular thread there itself. Even here also I am printing the information about current thread. No, I don't want to print the information about current thread. Directly I want to change the names. I know the names by default already in the sense. You can take the help of this one. See, here f dot set name. Here I am changing the first thread name as first. Later I am retrieving the name of the first thread. You can see here I am creating an object for second thread. For that name I have set it as second, as well as I am retrieving the name of that particular thread also. You can check it out. See, the names is changed to first as well as second. Okay now?
Yeah.
Yes or no? Yes. This is how you need to change the names for your thread. Setter and getter functions are there for updating the names of that particular thread. Remember this point. Next, we'll go for next one. In this program, how many threads are there? Check it out properly. Sir. Sashi,
Yeah. Yeah. Two, right?
two threads. Okay, fine. Let me tell you. There are totally three threads available. Got my point, right?
Yeah.
There are three threads. How come three threads? You might ask me. This is first thread.
Class. Yeah.
This is second thread.
Okay.
And where you are creating the objects, this portion is what called as your default main thread. Is that clear?
Okay.
So totally three threads are there in this program. If you ask me the proof, you can see I will print threading dot active count. How many threads are there? It will be printing the count of that particular thread. Is that clear?
Yes.
Now, if you want to see complete information about that particular thread in the sense, you can take the help of this one. See, threading dot enumerate. This will give you the information about that thread. That means list of the threads available in this program, complete information it will give you. Now, if I run this, see, count is 0, 3. And enumerate, if you see, first thread name is main thread and it is started with this particular value. Second thread, third thread. Totally three threads are there. Got my point, right?
Yeah.
Any doubts so far? Yes or no? Okay.
No.
Okay, fine. So we got to know how the threads and thread delays, everything will be happening. Now we will see next one. Next one is after performing operations, what is the use of this thread to be alive? We can kill the threads, right?
Yes.
Yeah. If you keep it alive, it will be memory wastage only. So to kill that particular threads, what we are doing, you can see this way. F dot E is alive. We are checking still if it is alive. F dot join. We are killing the thread. Join is a function which is meant for killing your thread. Is that clear?
Yeah.
We are checking if it is alive. We are calling it for join. Even this one also we are checking if it is alive. We are calling it for join so that your thread will get destroyed. Okay, na?
Yes.
Any doubt so far?
No. No.
Okay. Next. Let me stop this. Okay, it is stopped anyway. Now I'll comment this one. So we got to know how a thread can be renamed, how to start up the thread, how to get to know the information about the thread, all these things we got to know. Correct, right?
Yes.
Now, one important interview question. That is, instead of using start, if I use run, what happens? Yeah, both of you. Instead of using start, if I use run, what happens is what my question. Could you please tell me?
It will run the program. No.
It runs the program. Previously also start was running the program, right?
Okay.
Was it by using start only we can create the thing. So what happens if I use run? That is what my question.
To recall the functions again.
No. See, if you use start, it will follow specific life cycle methods. That means proper life cycle methods of thread it will follow and it will perform the operations. Okay, na?
Okay.
When it comes to run, if you use, it won't behave like a thread. It will behave like a function. Got my point,
Okay.
right?
Yes.
It behaves like a function and it performs the operation like a function. See, that means selfish. First function will start. So IE only will get executed. Once the first function operation is completed, then only second function will start. Even though there is a delay, it will not give the chance for second function. Got my point, right? Yes or no? Yes. That is what. In interview, they'll ask, what will happen if I use run instead of start? Will this get executed or not? Most of us, we will say it won't get executed. It will get executed, but it won't perform the
Behave.
operations like a thread. It performs the operation like a function. Yeah,
Okay.
na?
Yes.
Can I have the next one?
Yeah.
Mm.
Yeah. So this is what your threading is all about. Now we are going to see what is meant by thread synchronization, otherwise thread locking. Okay, na?
Yes.
Thread
Okay.
synchronization, otherwise thread locking. Could you please tell me what is meant by thread synchronization?
Mm.
Hmm. Yes.
Um,
Hello. Are you guys with me? Okay. Right on. Thread synchronization. Thread synchronization is a thread synchronization is a process of hmm, is a process of executing only one thread at a time. Thread synchronization is a process of making only one thread to be executed at a time. Clear, right? Yes. So, what is the purpose of this particular, what do you say, thread synchronization? What we can do? Tell me.
It will execute only one thread at a time. At that time, the other thread will be in sleep mode.
That's it?
Yeah.
Okay. Fine. Okay, how to explain this? Say, let's say me and Seshi, we thought to take class in this particular go-to meeting. Okay, na? We both are trainers. Okay, na? Let's assume like this. We both are trainers. We want to use this particular go-to meeting for taking classes. Now, first, what Seshi will do, Seshi also will come, myself also will come. Seshi will behave very politely like a thread. He will say, yes, after my class, I will give you the go-to meeting link. You can continue with your class, he will say. Even I will trust him. I will say, okay, after your class, you just let me know. I will give him the chance. What he will do, once he got that particular link and credentials, what he will do, even if his class is done, he won't give me the chance to take over the classroom. Got my point, right? He behaves like a thread. But once he got the credentials, once he got a grip on that particular tool, he will not give me the chance. He will perform his operations even if it is a delay. I mean, if he is not using that particular credentials, if he didn't have classes also, he will be wasting that credentials. He only will be occupying that one. That is what thread synchronization. He will not give the chance for other person. Once his chance is over, I mean, once his operations are done, then he will leave the room and he'll go off. That is what thread synchronization, where again I can take up, even I, anyway, Shashi has cheated me. He didn't give me the chance. He has utilized my resources. So what I will do, even I will behave like a selfish person. Even I will not give the chance to him to utilize whenever I am free. Like this, thread synchronization will work in our programming. Got my point, right? Sashi?
Yes, Radar.
Yeah. So in this concept, what happens, if you just check it out, Sashi will enter into the room and he will lock that room. Correct now? Sashi will enter into the room, he will lock that particular room. Whereas myself also, I will enter into the room, I will lock the room when I got the chance. Like this, both of us, we will be wasting this particular resource. Whatever the resource we have got, we won't be using it properly. We will be wasting this particular resources. That is what thread synchronization is all about. Okay, now is that clear? Yes. Where this particular thread synchronization, if you are using, it is very much similar. It is almost similar to your function concept only. but compared to function, the performance will be slightly better. Got my point, right? Compared to function, this will be having better function, better performance, because threads are lightweight, right? So only. Any doubts so far? Can I have the next one? Yeah. What is this thread synchronization? What is thread locking? All these things in tomorrow's session we are going to discuss. Okay? Yes or no? Okay. See you tomorrow, same time, for thread synchronization and other concepts in Python. Okay? Bye.